Welcome back to the Strategy Room. Today, we are going to completely transform how you approach your Cambridge physics exams, specifically looking at light rays and waves fundamentals. We are going to treat your physics answers like a block of marble. We are going to chip away all the irrelevant, messy fluff and reveal the absolute masterpiece of an answer underneath. If you're studying syllabus 0625 or even 0651, 0652, 5054, or 9702, you absolutely know the feeling of staring at a blank page, just praying your brain perfectly recalls a textbook definition. But today, we are moving entirely away from that kind of basic, rigid memorization. I want to introduce you to two students you might recognize. Let's call them Alex and Sam. Alex overloads every single exam answer with raw physics facts, writing paragraphs of trivia but providing zero actual analysis. Sam, on the other hand, rushes. Sam sees a question, panics, and completely misses the command word requirements, losing easy marks. If we looked at their exam papers right now side by side, we would see a sea of red pen marks. We are going to fix that today. We are going to build a true, concept-first understanding that allows you to tackle absolutely any question the Cambridge Examiners throws at you. Here is our roadmap for today's explainer, designed to give you the ultimate physics exam strategy. First, we've got the starter question, where we decode exactly what the examiner is asking. Second, we dive into the four-step strategy, introducing a framework that top students use to perfectly structure their answers. Third, mastering cause and effect, where we transform your raw knowledge into a beautifully logical sequence. Fourth, we are going to look at common exam traps, running through some interactive challenges to spot where students like Alex and Sam bleed marks. And finally, number 5, the quick recall system, to lock this all into your long-term memory.
Section 1. The starter question. Making physics absolutely necessary. We need to stop looking at physics as just a list of things you have to memorize for an exam and start looking at it as a toolkit to solve real physical problems. When you look at a Cambridge past paper question on light rays, the very first thing you need to do is decode it. You need to look at the specific assessment objectives the examiner has hidden in the wording. This is where the strategy begins.
Now, look at this question on the screen. What physical effect, measurement, or prediction depends entirely on understanding light rays and waves? Before we break down the command words here, I have a quick announcement. Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, let's get back to it. Asking yourself this exact question before you sit down for an exam makes you far less dependent on memorized, rigid wording. Before you even write down a single equation for wave speed or refraction, ask yourself why scientists even bothered figuring this out. When you know the why, the how becomes infinitely easier to remember. Formal physics language is completely useless if you do not understand the real-world physical effect it actually describes. If the command word is describe, you state what happens. If the command word is explain, you must state why it happens using physics principles. Sam always misses this distinction. Don't be like Sam. You have to anchor the concept in reality before you even think about introducing the formal language. This is where Alex goes wrong. Alex will read a question about light passing through a glass block and immediately write down 5 lines of dense physics definitions about the electromagnetic spectrum, without ever answering the specific question. By making the core idea feel absolutely necessary rather than just decorative, you empower yourself to reason your way through completely unfamiliar exam questions. If a question introduces a bizarre scenario you've never seen before, your grounded understanding of the real-world physical effect will guide you right to the correct answer. You chip away the panic, and the physics masterpiece remains. Let's move to Section 2, the 4-step strategy, also known as the 0625 syllabus reasoning sequence. This is where we introduce the Peel framework to your physics answers. Peel stands for point, evidence, explanation, and link. It is a structure widely used in essay writing, but it is a massive secret weapon for structured physics questions. It guarantees that you hit every single marking point on the examiner's rubric. The crucial point here is this 4-step linked sequence. This perfectly mirrors the Peel framework and is the ultimate gateway into demonstrating both understanding and application to your examiner. Step 1. Identify the quantity or phenomenon. That is your point. Step 2. State the symbolic relationship involved. That is your evidence, where your formulas and equations come in. Step 3, explain the underlying physics. That is your explanation. And step 4, connect it to an observation, experiment, or real device. That is your link. If you consistently use this four-step sequence in your IGCSE style physics exams, you are telling the examiner that you do not just know isolated facts, you know exactly how to structure an undeniable high-scoring argument. I want you to imagine a 30-second timer in your head right now. If you were given a question on total internal reflection, could you map it to these four steps? Give it a try.
Section 3. Mastering Cause and Effect. Transitioning your everyday language into precise physics vocabulary. This is where the transformation really happens. This is where we take the red pen marks on Sam and Alex's papers and magically transform them into green check marks. We are going to rewrite their answers live by applying our blueprint, proving exactly why every single vocabulary change adds physical marks to your final score.
Constructing a top-tier answer is a journey, and this timeline is your physics success blueprint. You begin with a concrete, everyday concept. Maybe you're talking about a straw looking bent in a glass of water. Next, you transition and slowly introduce the formal physics vocabulary. You stop saying bent and you start saying refracted due to a change in optical density. Only then, when the foundation is perfectly set, do you introduce the symbolic relationship or definition, like Snell's law. Finally, you conclude with a fully worked explanation. You do not just jump straight to the math. You build a beautifully engineered bridge from reality to the calculation, taking the examiner by the hand and walking them directly to a full mark score. Let this quote become your ultimate exam mantra. Insist on cause and effect rather than isolated facts. Keep this in your mind at all times. Whether you are dealing with fields, forces, particles, circuits, or, in our case today, waves, this specific philosophy is the literal difference between an average grade and a perfect Cambridge score. Examiners are completely exhausted by reading lists of disjointed trivia. They want to see the chain reaction. They want to see exactly why thing A causes thing B. Stop scrolling. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Now, applying that cause and effect is incredibly important when we look at data sources. When your exam topic involves analyzing complex graphs, which it absolutely will in the 0625 syllabus, you must always stress exactly what these specific visual elements represent physically in the real world. Don't you dare just write the line goes up. That gets you 0 marks. Explain what the slope actually means. Does a steeper gradient mean a higher wave frequency? What does the area under the curve represent? What physical reality is dictated by the direction or the shape of that wave graph? If you just describe the ink on the page, you fail. If you describe the physical reality the ink represents, you succeed.
Let's move into our interactive workshop for today. Let's look at where this lives outside the classroom. Challenge number 1 is a data scan. Imagine a 60-second timer ticking down right now. I want you to look at these fields on the screen: medical technology, astronomy, transport, energy, communications. If I showed you a complex data table mapping the frequencies of the electromagnetic spectrum, could you extract the core trend and link it to one of these fields in 60 seconds? You should always be able to name at least one real situation where the concept matters: X-rays in medical technology, radio waves in communications. If you can extract the data trend and explain exactly why the physics helps us predict outcomes in the real world, your exam answers will have an incredible amount of depth. Welcome to Section 4, Common Exam Traps. This is specifically where students lose marks. We are moving to challenge number 2 of our workshop, Find the Flaw. I am going to show you exactly how students mess up, and you are going to spot the specific sentence that destroys their grade. Here is the first massive trap, and this is exactly the flaw we see all the time. Look at how an invisible student loses marks instantly by just dropping a formula onto the page without showing the examiner they actually know what the letters mean. They write V equals F lambda and then they stop. That is the trap. Writing the correct formula but entirely abandoning the variables. The examiner thinks, well, they memorized a bunch of letters but they have no idea what it actually means. The triumph, the way you get the marks, defining the relationship, stating the formula, and explaining each variable clearly. V is wave speed in meters per second. F is frequency in hertz. Lambda is wavelength in meters. You leave absolutely 0 room for doubt. Here is another massive trap, and it brings us to challenge number 3, speed writing. The trap is quoting a process without linking it to a physical effect. Never just state that something happens. A student writes, refraction happens. Okay, great, but why? You must always provide the physics justification that shows exactly why it follows from the core principles. The triumph is explaining that underlying physics cause and effect chain. Now imagine a 30-second timer counting down on the screen. Your speed writing challenge is to write one perfect Peel paragraph on refraction. Point, light changes direction. Evidence, it enters a denser medium. Explanation, the wave speed decreases causing the wavefronts to bend closer to the normal. Link, this is why a lens can focus light. 30 seconds. That is all it takes to build a perfect examiner-pleasing paragraph.
Let's bring this all together into the final system. This table is your ultimate cheat sheet, showing the safe method pathway: definition, relationship, explanation, application. And right next to it, the common weaknesses you must avoid. This ties perfectly into the 3 rules that absolutely guarantee top marks. Rule 1. Command word decoding. Don't skip directly to the example without defining what the command word asked for. Rule 2. Peel framework application. Don't state isolated facts, build a relationship and an explanation using point, evidence, explanation, link. Rule 3. The time management matrix. Don't waste 10 minutes giving application examples with no physics link or forgetting physical graph meanings. Stick to the safe method, chip away the fluff, and manage your time perfectly.
Section 5. The quick recall system. Securing your knowledge. We have built the framework, we know the traps, now we need to make sure this stays in your head until the exact moment you open that exam paper.
Look at these 4 prompts. If you can sit down at your desk and answer these 4 specific prompts out loud without looking at a single textbook or note sheet, your knowledge of light rays and waves is absolutely rock solid. Try it right now. Number 1, what is the core idea? Number 2, what changes physically in the real world? Number 3, what quantity, formula, or graph shows it? And number 4, where is it used in everyday life? Speaking these answers aloud forces you to articulate the complex concepts, exposing any tiny gaps in your reasoning long before the examiner ever gets a chance to see them. It is the ultimate self-audit.
I want to leave you with this final thought. Mastering physics isn't about rote memorization. It's about understanding the fundamental rules of the universe well enough to explain them to absolutely anyone. Will you rely on basic memorization, just hoping the exact wording from the textbook magically comes back to you in the exam hall? Or will you build a logical, structured cause and effect masterpiece? Students who implement these physics strategies see an average improvement of 2 whole grade boundaries. But that only happens if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for physics and the biggest challenge you're facing right now. Our team responds to absolutely every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.